What if I told you that the secret to saving a dying, rare, exotic plant isn't actually found in some expensive imported soil?
Right. Or, high-tech automated grow lights or anything like that.
Exactly. What if the secret actually comes from completely ignoring that fancy plant and while studying the weeds growing out of the concrete in your driveway instead?
It sounds totally counterintuitive, I know.
Yeah.
But those completely neglected, unkillable plants that are just thriving in the absolute harshest microclimates, they actually hold the blueprint for real botanical resilience.
Yeah, and that's exactly what we're getting into today. Welcome to this deep dive. We are exploring a super fascinating source that pretty much turns our whole traditional understanding of what a scientific laboratory is completely upside down.
It really does.
So we're looking at a blog post, and it's titled The Sanctuary Laboratory, Reflections on Tropical Cultivation. It was published on May 20, 2026. And, what makes this specific document so remarkable is that it marks the author's, Ang's 900th post milestone.
Which is huge.
Eh.
I mean, jumping from their 800th to their 900th post represents this massive, meticulously documented archive of just pure trial and error.
Yeah, 900 posts is basically a longitudinal study in adaptation at that point. And the focus for us today is how these really unexpected limitations forced Aang to change everything. Like, they were dealing with a brutal tropical rainy season combined with some pretty frustrating bouts of poor health.
Right, which meant they had to completely abandon their usual field trips out to nurseries and parks and stuff.
Exactly. They couldn't actually go out into the world. So they brought that whole spirit of scientific inquiry right into their own garage and backyard. Over the past 3 months, Aang just transformed their home garden into this living lab.
But, when we normally think of a laboratory, we usually picture, like, climate-controlled sterility.
Oh, totally. White coats, everything isolated, super quantifiable and neat. But Aang's lab is literally the exact opposite of that.
Yeah, we're talking about just erratic tropical weather that violently swings between scorching heat waves one minute and torrential downpours the next.
It's the absolute definition of environmental muddy waters. I mean, trying to cultivate fragile little seedlings in those conditions, you have to engineer a physical setup that can absorb some incredible environmental whiplash.
The margin for error is just incredibly thin, especially when the ambient temperature can, spike dramatically in the afternoon, and then it's followed immediately by an inch of rain in like an hour.
Right. And that kind of crazy weather profile just forces a grower to reevaluate everything. And that starts with the actual physical containers that are holding the soil.
Which is where it gets really interesting.
Yeah, because I always assumed terracotta or like thick ceramic would be the gold standard for outdoor tropical growing. But Aang found that their absolute best performing seedling containers were actually just EPS foam cups.
Wait, really? Just normal foam cups?
Literally just standard cheap foam cups. And they paired them with these really inexpensive plastic plates to act as plant saucers to catch the runoff. It was all just to manage those chaotic watering needs we talked about.
That is actually a brilliant application of thermodynamics, when you think about it.
How so? Like, why foam over plastic?
Well, standard dark plastic nursery pots are just terrible insulators. In a tropical heat wave, solar radiation hits that dark plastic, and the thermal energy transfers straight through the thin wall directly into the root zone.
Oh, wow. So it just heats up the dirt.
Exactly. You end up literally cooking the delicate root hairs, which just halts nutrient uptake entirely. The plant basically starves.
And I guess recycled cardboard pots, which are, super popular for seedlings, those would just structurally disintegrate after a few days of heavy tropical downpour.
Right. They'd turn to mush, which is precisely why EPS foam is so superior in this specific extreme environment. Polystyrene foam is predominantly just trapped air.
And air is a bad conductor of heat, right?
Exactly. Because air is a remarkably poor conductor of heat, the foam acts as this amazing thermal isolator. So the ambient air temperature outside might be spiking, but the internal soil temperature inside the cup stays totally stable.
That makes a lot of sense. It prevents heat stress in the root zone while simultaneously holding on to that vital moisture.
Yep, the roots are completely thermally protected.
But, okay, that still leaves the top of the soil exposed to the actual physical violence of the rain, right? So Aang designed this really cool dual-layer mulching system to cover the soil. They combined coconut coir with LACA
What is the
balls.
ACA balls?
Yeah, for anyone listening who might be unfamiliar, LACA stands for lightweight expanded clay aggregate. It's basically just these porous baked clay pebbles, and I initially thought this was purely about moisture retention.
Oh, it does way more than that in tropical storm.
Right, looking at the mechanics of it, this mulch acts like a physical breakwater, doesn't it? It's almost like high-tech shock absorbers for the dirt.
That is the perfect analogy, honestly. High-tech shock absorbers. Because consider the kinetic energy of a large raindrop falling during a tropical downpour.
It's moving fast.
Right. And when thousands of these heavy drops hit bare potting soil, they don't just water the plant. The kinetic impact literally shatters the soil structure. It drastically reduces the macroporosity, which just leads to immediate soil compaction.
And it probably splashes everywhere, too.
Oh, it physically excavates the soil. It splashes dirt and potential soil-borne pathogens right up onto the underside of the delicate leaves.
Which is how you get diseases. But the LACA balls, they basically dissipate that kinetic energy. It's like Kevlar armor for the soil ecosystem.
Exactly like Kevlar. The rain hits the hardened, porous clay pebbles first. That breaks the surface tension and slows the velocity of the water way down before it ever even reaches the actual soil layer.
So the kinetic energy is absorbed by the mulch rather than just compacting the dirt into cement.
Exactly. And beneath that LCA layer, the fibrous coconut core is acting like a giant sponge. It traps the moisture that's being shielded by the clay pebbles above it.
Which prevents rapid evaporation when the weather inevitably snaps back to a scorching heat wave the next day.
Right. So Aang essentially engineered an armored microenvironment here.
Yeah, the foam isolates the roots thermally, the plastic saucers manage the unpredictable hydration, and the LSCA and core breakwater physically protects the soil structure from kinetic impact.
It's a seriously robust setup.
It really is. And with that whole infrastructure in place, they could actually start scaling up their propagation experiments because, they didn't just want a few plants. They basically wanted to manufacture clones.
And scaling propagation is really where a garden truly becomes a laboratory. Aang started with these coleus cuttings, and they utilized a pre-soak method.
Right. They submerged the cuttings in a diluted rooting hormone solution for like 24 hours, right, before moving them into water jars.
Yep. And that produced these bushy, super aggressive root systems in just a matter of days.
The speed of that root development is staggering. I mean, the rooting hormone, which I understand is typically a synthetic auxin, like a indole 3-butyric acid.
Exactly right.
It essentially hacks the plant's internal messaging system, right? Like it overrides the normal cellular function at the cut site and triggers cellular dedifferentiation.
Yeah, it literally forces the undifferentiated cell, the callus tissue, to immediately alter their gene expression.
So they stop behaving like stem cells and just rapidly begin generating root tissue instead.
Exactly. It's a complete biological override.
But then Aang applied a totally different technique when they were propagating their Brazilian tea shrub. Instead of using long stems for the cuttings like you normally would, they utilized what they called single-node propagation.
Which is such a smart pivot.
Yeah. They took these tiny cuttings consisting of just one single node, which is, the specific point on a stem where a leaf or a branch emerges. But wait, I have to ask, why would a single node propagation work better than using a whole long stem?
Oh, it's all about the metabolic math. It's entirely different.
How so? Because my first thought is, wouldn't you want a bigger stem with more leaves to gather more sunlight?
You'd think so, but remember, a cutting with no root system has a highly finite amount of stored carbohydrates and survival energy. If you use a long stem with multiple leaves, the plant's internal auxin gradients become totally chaotic.
Because it's trying to keep all those existing leaves alive.
Exactly. It is desperately expending its super limited energy, trying to maintain all that existing foliage, while simultaneously attempting to construct a brand new root system from scratch.
So it's basically spreading its metabolic resources way too thin.
Far too thin. By isolating just a single node, Aang fundamentally altered the resource allocation. There's virtually no existing biological infrastructure for the plant to maintain.
Wow. Okay. So 100% of that localized auxin concentration and stored energy is just forcefully redirected into a single task, which is pushing out roots.
Exactly. It's a highly localized survival mechanism, and it allowed Aang to create dozens of successful, really robust clones from just a single parent plant.
It's like they built a green assembly line in their garage. And they carried this mass production mindset over to seeds as well. They specifically focused on these affordable, really reliable herbs like sesame and common mustard.
Right, because their germination rates are just so high.
Yeah, Eng used them basically as biological indicators. They
Mm.
were testing the viability of different microclimates all around the yard. It really was an assembly line, foam cups lined up, seeds popping up with near perfect reliability moving right down the conveyor belt.
But, pushing that volume of new plants into various corners of a garage in a backyard, that introduces a massive new variable, which is microclimates.
Oh, for sure. Even a few feet of distance can drastically change the ambient humidity, the airflow, the light exposure.
Yeah, and that is exactly where the friction started. I mean, you can engineer the perfect foam cup, you can master the aux ingredients of a single node clone, but you just cannot control the ambient environment.
Nature always throws a curveball. The plants inevitably started throwing up these warning signs, which forced Aang to pivot from being like a production manager into a full-on botanical detective.
And honestly, recognizing and interpreting those physical stress signals is arguably the most complex skill in cultivation because the plants are constantly communicating their physiological state.
Mm.
You just have to listen.
Right. And Aang documented several really specific warning codes. It's kind of like a car's check engine light. The plant can't speak, but it's flashing these specific codes if you know how to read them.
That's a great way to put it.
The first one was etiolation, which they observed across their Thai basil, their sesame, and the variegated Mexican mint. And for anyone who hasn't encountered this, etiolation is incredibly distinct to look at.
It really is. The plant just stops growing healthy, compact leaves.
Yeah, instead it stretches out. It becomes super long and spindly and noticeably pale. What is actually happening there?
Well, it's a biological phenomenon known as shade avoidance syndrome. Plants possess these photoreceptors called phytochromes, and they constantly monitor the ratio of red to far red light in their environment.
Okay, so they are constantly checking the light spectrum.
Exactly. So when a plant is placed in a microclimate that lacks adequate direct sunlight, like, say, a shaded corner of a garage, these phytochromes detect that altered light spectrum.
And the plant basically realizes it's in the shadow of something else and physically panics.
That's exactly it. It immediately reallocates its energy away from producing chlorophyll.
Which is what causes that pale yellowish color.
Right, and it pumps everything into rapid stem elongation. It is literally stretching its neck, just desperately trying to outgrow whatever it assumes is blocking its light.
Wow. And Aang astutely recognized this etiolation not as a disease, but as a direct environmental response to those microclimates that lacked full sunlight.
Exactly. But the other major warning sign Aang encountered was much more severe.
Yeah, the mild interveinal chlorosis that appeared in the holy basil. Interveinal chlorosis is visually striking. Like, the veins of the leaf remain a dark, healthy green, but the tissue between the veins turns entirely yellow.
It leaves the leaf looking almost like a skeletal X-ray.
It's super spooky looking. And Aang correctly diagnosed this as an iron deficiency, right?
They did. But this is where the environmental troubleshooting becomes highly technical, because identifying an iron deficiency is really only step one. The critical question you have to ask is why the iron is deficient.
Right, because if you're listening to this and you've ever watched one of your own potted plants slowly yellow and die, despite the fact that you are constantly feeding it fertilizer, this is why. The issue usually isn't an empty soil bank.
No. In most cases, the iron is abundantly present in the soil matrix. The plant simply cannot access it. And Aang actually traced the root cause of this chlorosis back to the intersection of the soil composition and the extreme weather.
Right, because the holy basil was planted in this alkaline, heavy clay soil.
And clay soil is notoriously dense. The particles are so microscopic and so tightly packed together that there's very little macroporosity.
So when those heavy tropical downpours hit, the water doesn't drain, it just pools and completely saturates the heavy clay.
And that saturation creates an anaerobic environment. The roots are literally suffocating without oxygen. But, the chemical lockout is the true culprit here.
The chemical lockout.
Yeah. Iron in the soil typically exists in different oxidation states. For a plant root to actually absorb iron, it generally needs to be in a specific soluble form, often the ferrous state.
Okay, but Aang's soil was alkaline.
Right. That alkaline pH combined with the heavy waterlogged clay chemically alters the iron into an insoluble ferric state.
Oh, wow. So the nutrients are physically present, but they are chemically locked away.
Exactly. The soil is effectively holding the nutrients hostage. The plant is literally starving to death while surrounded by an abundance of iron simply because the ambient microclimate and the soil chemistry are incompatible.
That is wild. It completely shatters the illusion of control, doesn't it? It proves that you cannot just force any plant to live in any dirt, no matter how much fertilizer you dump on it.
You really can't. Matching the exact microclimate, the soil drainage, and the pH to the specific physiological needs of the plant is an absolute biological requirement.
And this realization is really the fulcrum of Eng's entire 900th post reflection. Because battling heavy clay soil, fighting anaerobic root conditions, constantly migrating plants to avoid etiolation, it is fundamentally exhausting.
Oh, incredibly exhausting. And when you compound that friction with the reality of Eng's bouts of poor health, the paradigm just had to shift.
Yeah, like why expend immense physical and emotional energy fighting the environment when you can just cultivate the plants that already thrive in it?
Right. It was a brilliant pragmatic pivot. Eng just stopped babying these fussy, difficult plants that required endless troubleshooting and heavily shifted their collection toward keeping and propagating tough, local, perennial flora.
They basically moved toward true botanical resilience. We were talking about species possessing immense phenotypic plasticity, right?
Yes, exactly. Phenotypic plasticity is just the ability to physically adapt to a wide range of harsh environmental conditions without suffering physiological failure.
And the specific species Eng adopted are fascinating. They went with the creeping Malaysian false pimpernel, Singapore rhododendrons, black nightshade, and cat's whiskers.
And these are plants that are uniquely evolved to handle the exact tropical whiplash, the scorching heat, the sudden torrential flooding, the dense clay that was actively killing the exotic basil and mint.
Which is where we hit this beautiful irony. Because the horticulture industry basically trains us to view gardening as an act of dominion. We spend vast amounts of capital and energy purchasing exotic species, engineering expensive soil amendments, monitoring pH levels, and battling chlorosis.
We completely trap ourselves in a sunk cost fallacy with these delicate plants.
All while completely ignoring the absolute botanical powerhouses growing in the cracks of the pavement. I mean, Eng explicitly notes that these local perennials, the false pimpernel, the rhododendrons, are the exact same resilient species that survive completely neglected along roadsides.
Or they're just thriving in untended public parks.
Yeah.
They are the very species the industry conditions us to aggressively pull up and discard as weeds.
But the weeds possess the actual botanical superstrength. They don't require EPS foam cups to buffer the heat. They don't need lessee breakwaters to protect their roots. Their genetic baseline is survival.
Exactly. And by recognizing their value and bringing them into the sanctuary laboratory, Eng finally aligned their efforts with the environment rather than constantly fighting a losing battle against it.
And that alignment fundamentally altered the psychological impact of the laboratory. By embracing resilient flora and dialing in a propagation system that actually harmonized with the climate, all that friction just vanished.
And dramatically reduced the cognitive and physical load of gardening.
Which ushers in the most profound insight of this entire archive, which they call the sanctuary of routine. When the anxiety of keeping fragile plants alive was removed, the physical chores required to run the laboratory completely transformed.
They ceased being a stressful obligation and evolved into a genuine mental sanctuary.
Yeah, Eng so eloquently details the therapeutic value of spending cool, quiet nights in the garage just performing manual labor, like washing dirt out of plastic saucers, reorganizing the propagation shelves, carefully transplanting the successful clones.
Even just having unhurried small talk with a neighbor passing by.
It is a profound shift from a product-oriented mindset to a process-oriented mindset.
That's a great way to frame it. Because when we garden solely for the product, the harvest, the bloom, the perfect rare leaf, we are inherently anxious.
We live in this state of deferred happiness, constantly checking for etiolation, worrying about the anaerobic clay, stressing that a sudden storm will destroy the flower before it even opens.
Right. The dopamine hit is tied exclusively to the final result. And if the result fails, the entire endeavor feels like a massive waste of time.
But when you become process-oriented, you totally detach from the outcome. The rhythm of the labor itself becomes the reward. The repetitive, tactile motion of taking single-node cuttings, or even just the simple act of scrubbing a pot. It becomes a mechanism to quiet an overactive mind.
The work itself is the meditation. And this psychological shift completely dictates Eng's trajectory as they look past post 900 and onto the road to their 1000th post.
Yeah, their future plans are entirely process-driven now. They intend to refine their garage setups with custom or purchased racks. They want to aggressively scale up the mass propagation of harvested and purchased seeds.
But crucially, they specify that this mass propagation is purely for the fun of it. It is not an enterprise for profit.
Right. They're cultivating an assembly line simply for the joy of operating it.
And they're also planning to return to their field trips to local nurseries and public gardens as their weather and health permit. But the intention behind these trips has evolved too.
It's no longer just about scouting new exotic species to hoard or taking macro photos for the blog. Ang describes these future excursions as a vital way to reconnect with nature, to purposefully revisit the nostalgia of their youth, all while navigating life in the middle of a concrete city.
And that specific framing, finding nature in the middle of a concrete city, that really contextualizes the true value of the living lab. It was never just an experiment in oxen gradients or thermodynamics.
No, it was the intentional construction of a natural refuge within an artificial environment.
It really brings everything full circle. Through 900 posts, Ang's journey has shown us the ingenuity required to engineer an armored microclimate out of foam cups and coconut coir.
We've explored the biological mechanics of single-node cloning and the really complex chemistry of an iron deficiency locked within heavy clay.
But the ultimate revelation was the wisdom to just stop fighting the storm. By abandoning fragile exotics and adopting the unkillable resilient plants thriving on the roadside, Ang found true peace in the process.
They took the frustrating limitations of extreme tropical weather and poor health and utilized them as a catalyst for a much deeper psychological discovery. The garage became a sanctuary. The mundane became meditative. We established at the very beginning that a traditional lab is defined by strict control and sterility. But Ang proved that true discovery doesn't happen when you force control over every single variable. It happens when you adapt to the chaos.
The science of cultivation is ultimately just the science of adaptation.
It really is. Which leaves me with a thought I want to share directly with you, the listener. We have spent this time unpacking the mechanics of Ang's sanctuary, but consider your own routines. If the deepest, most resilient joy of gardening is actually found in the quiet, rhythmic labor of scrubbing pots in a garage, rather than anxiously waiting for a flower to bloom, what is the equivalent mechanism in your life?
Oh, that's a good question.
What is a mundane, repetitive chore you execute every single week that you could consciously reframe today, not as a frustrating obligation, but as your own quiet, process-oriented sanctuary?
It is an essential question for anyone who's just navigating the friction of daily life.
It truly is. Well, thank you for joining us on this deep dive into the Sanctuary Laboratory. It has been a fascinating journey unpacking the science and the psychology of this archive with you. Until next time, keep adapting to the variables, keep refining your process, and maybe take a much closer look at those resilient weeds growing right out of the pavement. Take care, everyone.